Welcome back, everyone. Ready to dive into some seriously cool scientific breakthroughs?
Always. It's like a backstage pass to the universe's greatest hits.
Exactly. And today, we're taking our cues from Casey Malcobelli's recent article, Top 10 Groundbreaking Scientific Discoveries That Changed History.
Published, what was it, just last week, January 24th, 2025. So, fresh off the presses.
Piping hot and ready for analysis, we're going to explore these 10 discoveries, not just what they are, but how they still impact us today.
And trust me, there are some surprises and connections even seasoned science fans might not have realized.
Buckle up, because number one on Malcobelli's list is a heavy hitter, Einstein's theory of relativity.
Now, when most people hear relativity, their eyes glaze over. They think, oh, great, physics equations. But it's so much more than that.
I gotta admit, I'm guilty of that too. It sounds really abstract.
Mhm.
So break it down for us. How does it actually affect our everyday lives?
Okay, so before Einstein, everyone thought space and time were like the stage the universe played on. Constant, unchanging.
Right, like the background scenery that never moves.
Yeah, exactly. But Einstein comes along and says, nope, space and time are relative. They change depending on how fast you're moving or how strong gravity is.
Wait, so space and time can actually warp?
Kinda, yeah.
Yeah.
The faster you move, the slower time goes for you relative to someone standing still. It's called time dilation.
That sounds like science fiction.
Well, it's science FDCT, and we have to account for it with things like GPS.
GPS. What does relativity have to do with GPS?
Those GPS satellites are zooming around Earth super fast.
Right.
And because they're moving so fast, time actually slows down for them, just a tiny bit, compared to us down here.
So time is literally running slower for those satellites.
Yep. And if we didn't use Einstein's equations to adjust for that tiny difference, GPS would be useless. You'd end up miles away from your destination.
Wow, I had no idea relativity was that practical.
Oh, it gets even wilder. The theory also predicted things like black holes and gravitational waves.
Black holes, those things that suck everything in, even light.
Those are the ones. And gravitational waves, those ripples in space-time caused by massive objects, like when black holes collide.
It's mind-boggling that those were once just ideas on paper, and now we can actually detect them.
It makes you wonder what other seemingly impossible predictions from relativity might turn out to be true.
Right. Like, who knows what mysteries will unravel in the future, thanks to Einstein's genius.
Speaking of unraveling mysteries, let's move on to number 2 on Makubayo's list, Darwin's theory of evolution.
Oh, yeah, this one really stirred things up back in 1859.
It was revolutionary. Before Darwin, most people thought species were fixed, created as they are, no changes.
Right, like the story of creation.
Exactly. But Darwin comes along with mountains of evidence showing that species actually change over time through natural selection.
Ah, survival of the fittest.
The ones best suited to their environment thrive and pass on their traits.
Exactly. But it's not just about being strong or fast. It's about which traits help you survive and reproduce in a particular environment. So a really well-camouflaged bug has a better chance of not getting eaten and having babies. So those camouflage genes get passed on.
Precisely. And over millions of years, these tiny changes can lead to entirely new species.
So Darwin's work explains how we got this incredible diversity of life on Earth.
Right. And its relevance goes even further. Think about climate change.
Climate change, how does evolution play into that?
Well, as the planet warms, understanding evolution helps us predict which species might adapt and which might sadly not make it.
Ah, so we can try to conserve those that are most at risk and maybe even help some species adapt.
Exactly. And there's another critical area, antibiotic resistance.
Oh, right, those superbugs that are becoming resistant to our drugs.
That's evolution in action. As we overuse antibiotics, the bacteria that survive are the ones that are resistant, and they pass on that resistance.
So it's a constant race to stay ahead of the evolutionary curve?
It is. Darwin's work isn't just about the past. It's a crucial tool for navigating the future.
So we've gone from the vastness of space and time to the microscopic world of evolving bacteria. What's next on our scientific journey?
Well, since we're talking about fighting disease, how about the discovery that revolutionized that fight? Penicillin.
Ah, yes, number 3 on the list. Penicillin. It's like the OG antibiotic, right?
You could say that. Before penicillin, bacterial infections were often a death sentence.
A simple cut could kill you.
Exactly. So when Alexander Fleming stumbled upon penicillin in 1928, it was a huge turning point, and its impact during World War II was immeasurable.
Saving countless soldiers from infections that would have been fatal.
It transformed healthcare, gave us a powerful weapon against diseases that had plagued humanity for centuries.
But like you said earlier, there's always a catch. Overuse of antibiotics leads to resistance.
Sadly, yes. That's why it's crucial to use antibiotics responsibly and develop new ones to combat those resistant bacteria.
Right, it's like a constant arms race against evolution.
It is. Now let's shift gears and delve into the very blueprint of life itself. Number 4 on Machiavelli's list, the structure of DNA.
The famous double helix, Watson and Crick, right?
Them, and importantly, Rosalind Franklin, whose X-ray images were crucial to their discovery.
Ah, right. I've heard she didn't always get the credit she deserved.
Sadly, that happens sometimes in science. But her contribution was key, and understanding DNA's structure has revolutionized everything.
Medicine, agriculture, even criminal justice with DNA fingerprinting.
It's allowed us to understand how traits are passed down, how genes function, and even how to manipulate DNA itself.
Hold on, manipulate DNA. What does that even mean?
Think gene therapy, where we can potentially fix faulty genes to cure diseases.
Like replacing a broken part in a machine.
Kind of. And then there's CRISPR gene editing, allowing for even more precise changes to DNA sequences.
That's incredible. We're talking about rewriting the code of life.
We are. But with that power comes huge ethical questions.
Like designer babies.
That's one concern. We need to carefully consider the implications of this technology.
Absolutely. Speaking of implications, number 5 on our list is a discovery that changed how we think about illness itself.
You're talking about the germ theory of disease.
Hmm.
Before that, people thought sickness was caused by bad air or imbalances in the body.
You're kidding. Like miasma, right? Bad smells equal disease.
Yep. But then Louis Pasteur and others came along and said, nope, it's tiny organisms, germs, that make us sick.
That must have been a huge shock to people back then.
It revolutionized healthcare. Suddenly, we understood the importance of sanitation, sterilization, and vaccination.
Ah, so that's how we got vaccines.
Exactly. By understanding how germs spread, we could develop ways to prevent their spread and even train our immune systems to fight them.
It's amazing how a seemingly simple idea, germs cause disease, could have such a massive impact on human health.
It shows the power of scientific observation and experimentation to change the world. Now, get ready for a mind-bending ride, because next up is the strange world of quantum mechanics.
Quantum mechanics. Oh boy, that one always gave me a headache in school.
I hear you. It's a world where the usual rules of physics kind of go out the window.
Okay, give me an example. What's something weird that happens at the quantum level?
Well, imagine a coin spinning in the air. Before it lands, it's both heads and tails at the same time, right?
Sure, it's just probability until it settles.
Well, in the quantum world, particles can actually exist in multiple states at once. It's called superposition.
So a particle can be in 2 places at once.
It's more like it exists in all possible states until it's measured, and then it chooses one.
Okay, my brain is starting to hurt. But what's the practical use of all this weirdness?
Oh, it's huge EE. Quantum mechanics is behind technologies like semiconductors.
Semiconductors. What are those?
They're the building blocks of computers and smartphones.
Mm-hmm.
Without them, we wouldn't have the tech we rely on today.
So the phone I'm using right now wouldn't exist without quantum mechanics.
Nope, and that's just the beginning. Lasers, quantum computing, it's all based on quantum principles.
Wow, I guess all that weirdness has some serious real-world implications.
It does. And we've only just scratched the surface of what's possible with quantum technology.
Okay, let's take a break from the mind-bending quantum realm for a bit and talk about something a little more down to earth. The light bulb.
Ah, yes, the invention that literally illuminated the world, often attributed to Thomas Edison.
Right, though Machiavelli points out that like most great inventions, it was a collaborative effort, building on the work of others.
Exactly. But regardless of who gets the credit, the impact is undeniable. Imagine life before electric light.
Candles, oil lamps. I'd probably trip over everything in the dark.
It's more than just seeing at night. Electric light transformed society. Factories could run 204/7, shops stayed open later, people could enjoy nighttime entertainment.
It extended the day, made cities safer, changed how we live.
And even the humble light bulb continues to evolve. We've gone from inefficient incandescent bulbs to fluorescence, and now super efficient LEDs.
And even smart lighting systems you can control with your phone.
It's amazing how something we take for granted has such a rich history of innovation behind it.
Speaking of innovation, number 8 on Machiavelli's list is CRISPR gene editing, a technology that feels both futuristic and a little bit scary.
It's certainly powerful. Imagine having microscopic scissors that can cut DNA at precise locations.
Wait, we can do that now.
We can. It's called CRISPR, and it uses an enzyme called Cas9, guided by a molecule of RNA, to target and cut DNA sequences with incredible accuracy.
So scientists can go in and edit genes, like fixing typos in our DNA.
Exactly. It's being used in research to study genes, develop new disease models, and screen for drug targets. And the potential for gene therapy is huge EE.
Gene therapy, what kind of diseases could we cure with that?
Potentially, things like cystic fibrosis, sickle cell anemia, Huntington's disease, all by correcting the faulty genes.
It's mind-blowing. But like you said earlier, such power comes with responsibility.
Absolutely. CRISPR raises big ethical questions. How do we ensure it's used safely? Who has access to it? What are the long-term consequences?
These are questions we can't ignore. It's like opening Pandora's box, but for our genes.
It's up to us to use this technology wisely. Moving on to number 9. A discovery that's given hope to millions suffering from organ failure.
Organ transplantation. That's got to be one of the most incredible feats of modern medicine.
The first successful organ transplant, a kidney between identical twins, was back in 1954.
Wow, talk about a groundbreaking surgery.
Since then, we've come a long way. We can now transplant hearts, lungs, livers, kidneys, even pancreases.
And the success rates have improved dramatically, right?
They have, thanks to advances in surgical techniques, immunosuppressive drugs, and organ preservation methods. But a big challenge remains.
I'm guessing it's the shortage of donor organs?
You got it. There are far more people in need of transplants than there are available organs. And even with a match, there's always the risk of rejection.
Right. The recipient's body might attack the new organ.
Exactly. But there's hope on the horizon with research into tissue engineering and regenerative medicine.
Oh, right. Growing organs in the lab.
Scientists are making progress, using stem cells and other techniques. If successful, it could eliminate the need for donor organs altogether.
That would be revolutionary. Okay, last but not least, number 10 on Muckabilly's list takes us to the heart of matter itself, the Higgs boson.
The Higgs boson. This one's a bit tricky to explain, but it's crucial to understanding why the universe is the way it is.
You're telling me I remember hearing about its discovery back in 2012, but I never really understood what it was.
Basically, the Higgs boson is a fundamental particle that gives other particles mass.
Okay, hold on. How does a particle give other particles mass?
Imagine a swimming pool filled with water. It takes effort to move your hand through the water, right?
Sure, because of the water's resistance.
That resistance is analogous to mass. Now imagine a field that permeates all of space, the Higgs field. And the Higgs boson is like a ripple in that field.
Okay, I'm following so far.
When other particles interact with the Higgs field, they experience resistance, which we perceive as mass.
So the more they interact with the Higgs field, the heavier they get.
Exactly. Without the Higgs field, particles would be massless, zipping around at the speed of light, and nothing would ever form.
Wow, so this tiny invisible particle is basically responsible for the existence of, well, everything.
It is. And its discovery was a huge win for physics, confirming a long-standing theory.
So there you have it, folks. 10 groundbreaking discoveries that have shaped our world and continue to inspire new innovations.
From the vastness of space and time to the microscopic world of particles, it's been quite a journey.
We've covered relativity, evolution, penicillin, DNA, quantum mechanics, all these incredible breakthroughs that have changed how we understand the universe and our place in it.
And this is just the tip of the iceberg. Who knows what amazing discoveries await us in the future?
That's what makes science so exciting. It's a never-ending quest for knowledge, a constant reminder that there's always more to learn and explore.
And as we push the boundaries of scientific understanding, it's crucial to remember the ethical implications of what we discover.
Absolutely. Power without responsibility can lead to some dangerous places.
It's up to all of us to engage in these conversations and ensure that science is used for good, for the benefit of all humankind.
Well said. So let's take a quick break, but don't go anywhere. We'll be right back to continue our deep dive into these incredible scientific breakthroughs.
You know, it's amazing to think about how these discoveries, some of them centuries old, aren't just history. They're the foundation for so much of what we have today.
It's like each breakthrough sets off a chain reaction of knowledge, leading to even more breakthroughs in ways we couldn't have imagined. Like, take the theory of relativity. It wasn't just about warping space and time. It led to things like GPS, keeping us from getting lost.
And think about DNA.
Yeah.
Who would have guessed that understanding that tiny little double helix would lead us to gene editing CRISPR? I mean, we're talking about rewriting the code of life. It's kind of mind-blowing, isn't it?
Definitely makes you wonder what other scientific dreams might become reality. But before we get ahead of ourselves, let's take a step back and remind everyone what we've covered so far.
We started with Einstein's theory of relativity, a real head-scratcher. But it helped us understand things like GPS and black holes and gravitational waves.
Then we had Darwin's theory of evolution, which explained how life on Earth got to be so diverse. And it's still helping us tackle things like climate change and antibiotic resistance.
Speaking of fighting disease, we talked about penicillin, a true game changer. But it also taught us about the dangers of overuse and antibiotic resistance.
From there, we zoomed in on DNA, that double helix that carries all our genetic information. Understanding that opened the door to gene therapy, gene editing, all sorts of incredible possibilities.
And who could forget our trip into the quantum realm? That crazy world where particles can be in multiple states at once and things get really weird really fast.
But all that quantum weirdness is what makes things like smartphones and lasers possible. And don't even get me started on quantum computing. The potential is just mind-blowing.
From the microscopic, we went to something we all use every day, the light bulb. It might seem simple, but it completely changed how we live.
And then back to the cutting edge with CRISPR gene editing, a technology with so much potential, but also a lot of ethical questions.
We also explored organ transplantation, a truly life-saving procedure. But the shortage of donor organs is a real challenge.
And last, but certainly not least, we had the Higgs boson, that tiny particle that gives everything mass. And without mass, well, none of us would exist.
What a whirlwind tour of scientific discovery, right? It just shows how interconnected all these breakthroughs are, each one building on the last, creating this amazing tapestry of knowledge.
It really makes you appreciate the brilliance of all the scientists who came before us. It's like we're standing on their shoulders looking out at a whole universe of possibilities. But as we've seen, scientific progress isn't just about what we can do, it's also about what we should do.
Exactly. As we push the boundaries of what's possible, we have to think about the ethical implications too. It's not always a clear-cut path.
That's a really good point. So as we wrap up, I'm curious, what do you think of all the discoveries we've talked about? Which one has the most potential to change the future?
That's a tough one. They've all been so groundbreaking. But I think the ones that really deal with the essence of life itself, DNA and gene editing, those have the power to completely reshape our world.
I see what you mean. The ability to manipulate our genes is both exciting and scary. It could cure diseases, extend lifespans, but it also raises some big ethical questions.
Exactly. A powerful tool that demands careful consideration. And it's just one example of how science is constantly pushing us to think about what it means to be human.
Absolutely. So as we continue to make new discoveries, we need to have these conversations and make sure we're using our knowledge wisely.
Couldn't agree more. Science has the power to do so much good, but it's up to us to make sure it's used responsibly for the benefit of everyone.
Wow, it feels like we've just been on this whirlwind tour of the greatest scientific discoveries ever.
And the amazing thing is how each one, even the ones that seem super complicated, have actually shaped the world we live in today.
Like, we started with Einstein, right, bending our minds with relativity.
Yeah, and now, because of his theories, we have GPS. It's like, thanks, Einstein, for making sure I never get lost again.
Totally. And then there's Darwin. His work on evolution, it's not just about dinosaurs and fossils, it's helping us deal with, like, climate change.
And understanding how diseases evolve, which is, well, pretty important these days.
Speaking of disease, can you imagine what would we even do without penicillin?
It's crazy to think about. A simple mold changed medicine forever. But it's a good reminder that even with amazing discoveries, we have to be careful.
Yeah, like with antibiotic resistance. We can't just use them all the time without consequences.
Exactly. And then there's DNA, that incredible double helix. It's like the instruction manual for life itself.
Figuring out its structure was huge. It's led to all this amazing stuff, gene therapy, gene editing. It's like we're on the verge of being able to fix almost any disease.
The potential is mind-blowing, right?
Right.
But there are definitely some big ethical questions we need to grapple with.
No kidding. It's a lot of power to have. We need to be really careful about how we use it.
Absolutely. And then there's that other crazy one, quantum mechanics. It still feels like magic to me sometimes.
I know. It's like the universe has a secret set of rules that only work at the tiniest level. Particles existing in multiple states, entanglement. It's pretty wild stuff.
But all that weirdness is what makes modern technology possible. Think about it. Smartphones, lasers, even the internet. It's all built on those quantum principles.
It's incredible. And then we talked about something we probably don't think much about, the light bulb.
Right. It seems so basic now, but it completely changed everything.
Suddenly, nighttime wasn't so dark. People could work later, read more. It totally changed how we live our lives.
It's a great example of how even a simple invention can have a huge GE impact on society.
Absolutely. And then we talked about something that's just amazing to me. Organ transplantation. The fact that we can replace failing organs with ones from other people is incredible.
It's a real testament to human ingenuity and our desire to help each other. But of course, there are still challenges.
Yeah, like finding enough donor organs for everyone who needs one.
But research into growing organs in a lab is super promising. Imagine if we could just make new organs whenever we need them.
That would be a total game changer. And finally, we got to the Higgs boson, that tiny particle that explains why anything has mass at all.
It's mind-blowing to think that without the Higgs boson, the universe would be a completely different place. We wouldn't even exist.
It's a great example of how even the smallest discoveries can have huge implications. So we've covered a lot of ground today, from relativity to quantum mechanics, penicillin to the Higgs boson. It's been quite a journey through the world of scientific discovery.
And it just goes to show that there's always something new to learn, always more to explore.
Absolutely. The world of science is full of wonder and possibility, and who knows what amazing things we'll discover next.
That's what makes it so exciting, right? There's always that sense of mystery, of the unknown waiting to be uncovered.
So keep those minds curious, folks, and never stop exploring the world around you. You never know what amazing discoveries you might make.
And on that note, we'll wrap up this deep dive into the top 10 groundbreaking scientific discoveries that changed history. It's been a pleasure exploring these incredible breakthroughs with you.
Until next time, stay curious and remember, the future of science is bright, the possibilities are endless. Thanks for joining us.